Good morning. Today's Monday. Today we're going to introduce the next unit. I have not corrected the tests yet. I was waiting for more to come in. It looks as though only 3 people have handed them in. Remember that the grades that we have by the end of this week, this is the end of the marking period, are going to be your grades for the 5th marking period. Now you do have the opportunity to make up things that you have not done yet up until the end of school, but I strongly recommend you not doing that. I mean, make them up, yes, but don't wait till the end of school because things are going to continue to build. We don't have a lot of homework in here. In fact, we don't have any today even, but just stay on top of it. Just stay on top of it. About half of you have not done much of anything. So, okay, so today we're going to be looking at solutions, okay, the introduction to solutions. And you should have this note packet that was sent home, and it only has a couple of different homeworks in there. So we're going to use some of this, but a lot of it's calculations that we're not even going to go into. All right, so by the end of today, you should be able to identify and distinguish between 2 types of mixtures and define solution and solute and what an aqueous solution is. Okay, so those are the 2 goals for today, the 2 objectives. All right, so what do we have? We've got some distinctions that we need to make between solutions and mixtures. A mixture is a combination of 2 or more substances. Substances. Now remember, substances are either elements or compounds. Elements or compounds. And mixtures can also be classified. They're either homogeneous or heterogeneous. Now, we've already been introduced to this quite a while ago. So let's take a look. I've got a couple of mixtures here. This is basically water and sand. You can see the sand does not stay in the water for very long because it's more dense and it settles at the bottom. Okay, this is a mixture because I've got water and sand. However, would you call that a homo or a heterogeneous mixture? Well, since I can see the different particles in it, this is considered a heterogeneous mixture. Here's another mixture. Regular old Italian dressing. Now, even though I shake this around and eventually it will settle out, we still consider this a heterogeneous mixture. And why is that? Because I can see the different parts of it. It's not uniform. Okay? It's not uniform. And we've learned about this before. So this is a mixture, but it's heterogeneous. And thirdly, I've got Gatorade here. Now, Gatorade is a solution. It's a solution of water. It's got sugar in there, and then they've added other kinds of ions that they call electrolytes. This is a solution. And solutions are homogeneous mixtures. Another mixture that I could put very easily in here is the mixture that I just get out of the tap. Now, this is a mixture. It's got some crud in there, but this is a mixture, and this until when the gas finally disappears, it will be a homogeneous mixture. It's a mixture because it's not only water, but there are ions in there. Tap water has ions. So this is considered a solution as well, because I can't distinguish between the parts of it. All right? So what we're focusing on in this unit is what solutions are. And solutions are homogeneous mixtures. Homogeneous means it is the same throughout. And it also means that dissolved particles will not come out of solution. For example, we don't have any sugar built up at the bottom of this solution of Gatorade. Okay? Because of that, it is a solution. Clear particles are too small to be seen, of course, and they do not scatter light. Now, I didn't bring any milk today, but if we had a container, just a beaker of milk, and I shone light through it, you'd see that the light does get scattered. It kind of makes it look like a little bit of a cloud in there. And because of that, milk is considered what's called a colloid. So it's a different class and we don't really have to worry about it, but I'm just giving you an example. Okay, solutions will completely pass through filter paper. So if I put this through filter paper, it would catch all of these, and if I put this sand-water mixture through, it would filter out the sand. That's what I want it to do, probably. Okay? Next part is the solution is only a single phase. In other words, it's either going to be liquid, solid, or gas. So what I'm breathing in right now is a solution as well. Air is a solution. This is a solution as well. This is styrofoam. Okay? Styrofoam is a solution of something called styrene and air. It's pretty uniform throughout. Okay? It will not settle on standing. In other words, if I have this, I can shake this to the point where the sand will stay in the water for a little bit, but eventually it will settle to the bottom. So that's another reason why that is not a solution. And solutions can have color. I can have a beaker full of water and then put a drop of some sort of food coloring in there, and that would stay in solution. So that would be a solution as well. Okay? And the last little part here for today is distinguishing between solutes and solvents. The solute is the dissolved substance. Okay? Or if we have two metals, for example, it's the lesser, or two gases, it's the lesser quantity. It's the amount that we have less of. The solvent, on the other hand, is the substance doing the dissolving. And it's the greater quantity. So, for example, in the air that I'm breathing right now, I'm breathing air which contains nitrogen, oxygen, a little bit of carbon dioxide, there's some water, some argon. The solvent here is nitrogen because nitrogen is 78% of the air that I'm breathing in. That means oxygen would be a solute. Okay? So aqueous solution, in an aqueous solution, we've learned this before, I believe, but just to bring it back together, that's water. It's when water is the solvent. And this is the most common type of solution because water is such a great solvent. All right? And the last thing here is which of these substances will mix together to make a solution. So when it says soluble, Soluble means it will dissolve. If it's soluble, it will dissolve. So if I have a nonpolar solute, if I'm going to add something nonpolar, and the solvent is nonpolar, that means it's going to be soluble. What does that mean? That means if I've got, for example, here's another little setup I've got here. I've got two different substances here. The bottom is a solution. The bottom is a solution of water and food coloring. The top is lighter fluid, okay, like in a Bic lighter. So if I added gasoline to that, it will dissolve into it because they're both nonpolar. But as you can see here, I've got a nonpolar thing on top and water is polar. It's going to be insoluble. That's kind of like taking grease or a little pat of butter and trying to dissolve it in water. It's nonpolar. The butter is nonpolar, so is oil. And since water is polar, it won't dissolve into it. If I have a polar solute, back to this, since the food coloring will actually change and mix with the water, that means the food coloring is soluble. But if I have a polar substance with a nonpolar substance, it's not going to dissolve. So if I've got lighter fluid, which is insoluble, it won't mix with the polar water because like dissolves like, and in this case, they're two unlike. And lastly, ionic substances are essentially kind of like polar because they're charged. And in this case, they're insoluble. Okay? So fill those notes in for today. And then we'll pick up tomorrow. Okay? No homework today.